Okay, we're doing the two rotor system lab. This is our lab sheet here. What we've got is two rotors here, and they're free to move on the shaft, but they're held fixed to the shaft. So, as opposed to the previous experiment where it's fixed at the end. So they're free to move, but if we oscillate them with respect to each other, so twist one and the other, we can see we're getting, well, not quite, hard to get that right. We can see that we're getting equal and opposite movement of the rotors, okay? So that's our two rotor system. So what we show you here on the screen now is how that looks. Okay, so what I'm going to do is disturb the discs again and hopefully show you on screen how the waveforms look. As you can see now on the waveforms are 180 degrees out of phase with each other, and they have the exact same frequency. Now we can check the frequency of oscillation by just going frequency response here, and it's measuring it at 6.661. 6.661. We might just do that again. Okay, so what I've done is I've moved the rotors closer together. So our first L was 0.850. Now we're at 0.750, and we repeat the experiment as best we can. It's kind of tricky to do this, but you can see they are moving equal and opposite. And again, we do on the screen here, and we're getting a increased frequency of about 7.1, and then we can bring them in to 0.650, and again get a different in the experimental result and also the theoretical result. So I'll be showing you sample data for that. So with the two rotor experiment, all we're doing is we're changing the length between the two rotors. We're going from 850, 750, 650, and we'll have some typical data to show you on that. Just as a little thing, when I'm measuring the length, the distance between the rotors, there's a fair bit of error in this, because you can see here I'm just holding up a ruler like this and kind of doing it by eye. But exactly where a chuck clamps, there's a clamp there, there's a clamp there. So there's kind of an error there of at least around whatever the length of the chuck is, okay, which is about, I suppose, 20 millimeters, or not 20 millimeters, I can't even see what I'm doing. Yeah, it's about 25 millimeters. And plus there's a kind of a visual error here as well. So our length there, is subject to some degree of error, okay? We can say it's plus or minus 25 millimeters, but we'll talk about that later. So that's our two rotor torsion experiment over and out.